Hello, so here we're dealing with the problem number 9, and here we're given 2D array and we need to print elements from this array in a spiral form. So basically for this particular example we have to print elements in this way. So first of all, first row, then elements from the last column, each element. Then when we reach the bottom, we're just going to the opposite direction until we reach. So basically it will be like in this case. So to solve this problem we'll need 4, even 5 pointers. So first pointer will be the first index of a row. Another pointer, which I will call as L, will be the pointer pointing to the first column. Also the pointer for the last row and the pointer for the last column. And also I will use I, which will be iterator. So starting from the first element at the 0 row index and the 0 column index, I will define my iterator equal to L at the beginning, which also will be 0, and I will run my iterator until it will reach the end of this column. So I will print out all elements from my first row, which is at index 0. After that, once it will reach, I will point this k to the next row, and my iterator will be equal to k, so pointing to here, and from here we'll be printing element down to the bottom until it will reach the end, so until it will be less than m. Once we will reach to the bottom, we will just change our end column pointer to the previous index. So after that we'll be printing in this direction. So in this case our I will be so in this case we will be checking if our k is less than m, and our I will be n minus 1. So actually n is the number of columns, and we have to like always decrement it by 1 because the n is actually the size of the column and the m is the number of rows. So after that we'll be going to the another direction and decrement I value each time, and until it will reach the L, so until it will be greater or equal to L. Once it will reach it, we will just change our M and decrement it, so the number of columns will be like not 4 but 3. After that we'll be changing our iterator at I to m minus 1, and we will go to another direction until it will reach the k. So once it reaches the k, we will just decrement value of L, so our L will be pointing to the here, so basically it will go in this loop direction. So how it's gonna look like on a code. So here I already write down some beginning initial things of the code just in advance. So I'm using the m, and the m is the number of rows, while the n is the number of columns, and I is for iteration, and k is for starting index of a row, and L is the starting for the index of the column. So we will run our while loop until our k is less than m, and while our L is less than n. So within this while loop we also will use for loop. At the beginning I will be equal to L, and I will be run until it less than n, and will increment each time our I. Okay, so I write some basic stuff here. So I am just using console write because we want to print all these elements in one line. So here our row index is not untouched, since it's first row, so the index will be 0. Just we're changing the I value. After that, once we run this for loop, we're just increasing the value of the starting index of the row. So we're just from here we're going to the next row. After that, we're initializing another for loop. Here our iterator will start from k, which is 1, and will run until it will reach the end of the rows. So here in array, I will be pointing to the value of the row index, and the column always will be n-1, since it's pointing to the last index of the column. Also, we're concatenating space, white space, just to have a space between elements. And after this for loop, we're just decreasing the value of n, because we're done with the last column, so we're just changing the n value just to point to the previous column. Also, we're checking if our k still less than m. In this case, we're initializing another for loop. Here our I will be equal to the last column, and it will run until it will reach the first column, and it will always decrement. Here we'll also again use console write to print out all elements from the last row. So it's always last row, we're just changing the I of the column. And after that we'll just decrease the value of our end row. Other is we're checking if our first index of the column is still less than the number of columns. Here we're also initializing another for loop. Our I will be equal to the last the column number minus 1. I mean, not column number, but the row numbers minus 1, and it will run until it will be equal to the starting index of the row, and it will decrement each time. So here we're just printing each element from an array our I will be changing just the row values, and the column always will be the first column. And here after we will done with this for loop, we'll just increment the value of L. So here we're done with our code, so we can check it out. So starting from here, we see that our I is equal to L, which is 0, and we will run our for loop until it will reach the end of this row. So we're printing 1, 2, 3, 4 in this for loop, and after that we're incrementing the k pointing to the next row, and we're just printing all elements from the last column. And once we reach there, we're defining I with the last column -1, and starting from here we're going to opposite direction, printing all elements. Once we reach the first column, we will just define I with the last element of the row, but with the -1, because we need to skip to here, and we're printing each element until we will reach to the k. So after that we're just decreasing the value of m, and after that we're and here we're just defining the okay, so here we're starting from last row and going to the up and printing all elements. So we're just again using this while loop, and we will print all elements in this direction. So time complexity for this particular example will be order of m multiplied by n. So basically it will print all elements of array, and the time complexity will be the number of elements in the array, and space complexity will be O constant, because we're just defining pointers.